In this video, we're looking a little more in depth at sound waves. Let's start by doing a quick refresher. When we had the slinky and we made this little impulse in the slinky, what we noticed was is that a moment later, the little impulse had moved down the uh, through the medium here being the slinky. It had moved down to here, and then it just kept going. But if you also remember, I did another part where I scrunched part of the little coils. So if this is like your slinky, you've got a coil every so often. What I also did was I coiled some of them up and then I let that go. And after I let it go, what we saw was that had moved down to this spot here. And then a moment later, it continued to pass through. When we have this perpendicular, we have the energy of the slinky moving to the right and the impulse moving up. They're at a 90 degrees to each other, and this once again is called our transverse waves. But in this example, the impulse is here and the motion is there. They're in the same direction, and this is our longitudinal waves. Um, and these are how sound waves move. And if you haven't watched the other videos on that, you should probably do so. I really enjoy the Khan Academy demos on this that demonstrate it very nicely. The other thing we should know about sound waves is that they move through a medium, like I say, just like the slinky was here. But whether it moves through air or water or a piece of wood or a piece of steel, it moves through something, and the speed that it moves will change, and that depends upon the density of the material and the temperature of the material. It moves faster when things are warm. Let's do a couple practice questions. So, what is the speed of sound in air at 25 Celsius? So once again, from the previous slide here, I had the formula at the bottom. The speed is 331 meters per second plus 0.6. So here we go. So the speed is 331 meters per second plus 0.6 meters per second per degree Celsius. And then we multiply that by the temperature. So for question 1 here, we would simply take 331 meters per second, add on 0.6 meters per second per Celsius times 25 Celsius. And I've left all my units in here. You should see that the Celsius on the top here will cancel out with the Celsius on the bottom. And we're going to be left with meters per second and meters per second, which is good because we have to have the same units if we're going to add those numbers together. So the velocity is 331 meters per second plus 0.6 times 25. And that is 15 degrees. Oops, not Celsius, 15 meters per second. And that's how much faster sound will move at 25 than it does at 0. So that's going to give me 346 meters per second. So that's the speed of sound in air at 25 Celsius. Okay, second question, what about at -5 Celsius? So once again, I'm going to have the speed is 331 plus 0.6 times -5. And we're going to find that equals 331 plus, and that's going to be a -0. Oops, not a -0, -3.0. So the speed of sound at -5 Celsius will be 328 meters per second. Here I have a temperature. And, I want to know the temperature. I want to know the temperature And I know that the speed of sound is 350 meters per second. We're going to assume it's in air, and it's a good assumption to make unless we're told otherwise. So I know that 350 is equal to 331 plus zero point 0.6 times the temperature. And I want to know, what is that temperature right there? Okay, a little bit of algebra. I think the first thing I'll do here is I'll get rid of this 331. And now I have 300. Oops, not 300. Wow, going too quick. I have 19 degrees. Oh my gosh, 19 meters per second equals, let's slow down a little bit here, 0.6 T. Now what I'm going to do is I'm going to divide this by 0.6, divide that by 0.6, and I'm going to end up with the temperature will be 19 divided by 0.6, and I'm getting 31 and 2/3, or 31.666667 degrees Celsius. This question is getting into Mach numbers, and this is just putting things into a perspective in terms of how fast are they going compared to the speed of sound. So I've got a jet fighter flying at 800, and the air is 15 Celsius. So the first thing I'm going to do is I'm going to take this 15 Celsius and I'm going to figure out what the speed of sound would be wherever that jet fighter's flying. And it might be a different number if he's low to the ground or up high. So the speed of sound will be 331 plus 0.6 times t. So 331 plus 0.6, and I'm going to put a 15 there. And now I find that my speed of sound here is going to be 300 and what have I got? 340 meters per second. Okay. Now, part two to this question is how fast my fighter jet is traveling. And I notice that that's in kilometers per hour and this is in meters per second. And I need to compare the two, but I need to convert either the 800 into meters per second or the 340 into kilometers per hour. And it really doesn't matter which way you do it. So maybe I'll take my 340 and I'm going to do my unit conversion here. So let's see, I'm going to go switch colors here. Let's go 1 kilometer is 1,000 meters. So that gets rid of my meters are gone. And then I'm going to get rid of my seconds. Let's see, 60 seconds is 1 minute, and 60 minutes is 1 hour. And if I double check all my units here, let's see, my meters were gone. I have kilometers, and my seconds are going to cancel with my seconds, my minutes with my minutes. I got hours on the bottom. That's wonderful. So I'm left with kilometers per hour. So the speed of sound at 15 Celsius in air will be 340 times 60 times 60 divided by 1,000. My calculator tells me that's 1,224 kilometers per hour. So that's the speed of sound. Speed of sound in air at 15 degrees Celsius, right there. Okay, but what I want to know is the jet fighter going faster than the speed of sound? And it's obvious that he's not going the speed of sound. So if the jet fighter was traveling at 1,224 kilometers per hour, we would say he's doing or she's doing Mach 1. And if they were going half that speed, they're going at half the Mach. And if they're going double that speed, they're going at 2 times the Mach. So all we're going to do here in part 3 of this question is we would just simply take the speed of the jet, which is 800 kilometers per hour, and divide it by the speed of sound. And when we do that, we get a number 0. How about 2 digits? 65. There's no units here because the kilometers per hour cancel out the kilometers per hour. So basically, we're going at 65% of the speed of sound, SOS. So what does that mean? The Mach number, this is the Mach number, 0.65. That's the Mach number. And all it is, it's a comparison of your speed to the speed of sound. Just be careful that you have the units to be equivalent. All right, let's try one more question. Last weekend, it was beautiful. I went for a hike. It was 18 degrees Celsius. And, here it is. I'm walking and I made a scream and my voice traveled. And what happened was that it hit something and then it bounced back and I could hear it. And the time I heard it was 1.6 seconds after I did that. Now the temperature, careful, little t for time, big T for temperature. Temperature here was 18 Celsius. So the question I have is, what's the distance from here to here? So the first thing I'm going to do is I'm going to use my speed of sound, 331 plus 0.6 times the temperature. So I can see that the speed of sound on that day would be 331 plus so I'm going to have 341.8 meters per second is the speed of sound. So that's part 1. Now I'm going to use my basic kinematics equations and say, okay, so I know that the speed is the distance divided by the time. And I have the time. The time is 1.6 seconds. So the distance would be the velocity multiplied by time. So let's see. So my velocity here, 341.8 meters per second multiplied by 1.6 seconds. And we're going to see that the sound traveled a distance of 546.88 meters. But we're not done. Don't be confused. Why not? Well, what we have to remember is that the sound traveled from me to the wall and back again. So the distance that it traveled, so the distance the sound traveled, sound traveled was 546 meters. But that's not how far I am from the wall. My distance is half of that. So if I divide that by 2, I'm 273.44 meters away from the wall. Speed of sound, very helpful and not that challenging.